Okay, so let's go over what we did in our separation lab when we separated an unknown mixture into its components. We're going to review what we did, how we did it, and what we learned. So the objectives of this lab was to separate a mixture into its components using the processes of sublimation and decantation. Sublimation is when you heat something so that one substance turns into a gas and evaporates off. And decantation is the process of gently pouring to separate a solution from a solid component. Ammonium chloride is our compound that's going to undergo the sublimation, and we'll be left with a mixture of sodium chloride and sand. The sodium chloride is soluble, but the silicon dioxide is not. So when we wash the mixture, we're going to get the sodium chloride to dissolve while the sand gets left behind. So you can kind of summarize our procedures. We started out with our mixture here. Okay, we heated it, and when we were left, we had a mixture of ammonium chloride that sublimated and went out into the air, and then we were left with a mixture of sodium chloride and silicon dioxide. We added water, and the NaCl will dissolve and give us an NaCl solution. The silicone won't, so we'll be left with just some wet sand. Then we heated them both to dry them and get the pure compounds. Some key observations was that a white smoke when the ammonium chloride was sublimated, and the salt dissolved to create a clear solution while the sand was left behind. So here's some highlights of what we did. We sublimated, we decanted, as you can see here. We heated up our solutions in order to dry them, getting all the water to evaporate off. And we learned how to use an analytical balance, which has these doors to protect it from the wind or air flow in the room messing up our measurements. So here's some examples of our data and how we got our data. To figure out our mass of ammonium chloride, we took the mass of the dish and the sample minus the mass of the dish and the sample after sublimation. To get our mass of salt, we took the mass of the dish and the salt after we dried it and subtracted the mass of the dish by itself. To get our mass of sand, we took our mass of the dish and the sand after we dried it off and subtracted out the mass of the evaporating dish. That gave us our masses of all the compounds. To get the percents, we simply had to take the masses of our compounds, divide by the mass of our original sample, and times it by 100. And that would give us the percent of our sample that was those solutions or those substances. Okay. We also did some calculations to figure out how much recovery we got by taking the difference between the mass of our original sample and the mass that we recovered in order to get our percent recovery. Some common sources of error in this lab were we had some spilling during decantation, which led to lower percentages than to be expected. Or if you got higher percentages, it was because of not drying the sand or the salt well enough. In looking back, it really couldn't have been done in a different order. The ammonium chloride would dissolve, but then it would be impossible to sublimate it while evaporating the water and have those two processes be separate. And these methods can be applied to a lot of other mixtures. Anytime you're working with something that can be sublimated or can be dissolved and trying to separate it out from something that can't. And that was our lab.